Hey, hello guys, welcome to another training of ExploitPack. On this training, we will cover Mac internals. During Mac internals, you will see how an application bundle works on Mac, how to pen test those applications, the clients, how SIP and entitlements are implemented on Mac. SIP stands for System Integrity Protections. Since 2012, there are some security mechanisms that have been implemented on Mac. So we will cover those as well. But first before diving into Mac internals, let me cover ExploitPack Pro. That's one of our products. ExploitPack Pro is our security exploitation framework. You can compare it with Metasploit or Core Impact or Immunity Canvas. So basically, if you are looking for an offensive product with technical support and you want to achieve results that you might have been struggling with other tools, please take a look into ExploitPack. There is also a trial version. You can give a spin. There is also documentation available on our website exploitpack.com, and then you will you can check for it. Besides ExploitPack, we also have a simulation attack tool with C2 capabilities. You can compare this tool to, for example, CoverStrike, but the main difference with the control pack is that our agents, besides that being more user-friendly with a graphical interface and some capabilities that the other tools do not have. Well, the main differentiation is that our agents will be able to bypass AV and EDRs. So if you are looking for that, if you are looking for a tool with C2 capabilities, a tool that you can simulate attacks in real scenarios, a tool that will bypass AV and will bypass EDRs, well, Control Pack is your tool. And why do you want Control Pack? Because these agents will also help you learn about the techniques, the current techniques available to bypass AVs and EDRs, because our agents also are available as in source code, not only binary. So if you want to compile the agents yourself, not the tool, but the agents, you will be able to do it yourself. But by doing that, you will also see how we implemented these bypass techniques, capabilities, features that are needed for doing so. So you see our implementation of syscall bypass and so on, for example, for Windows, to just name one. But of course, our agents, they are not only for Windows, they are also available for Linux and Mac, and you can see those under source code of those on the back. So give it a try. There is no trial version. It's a product that we choose release, but the manual is already available, and we have a ton of users already enjoying this tool. And if you have questions, feel free to join us in Discord, and we will try to do our best to reply you or assist you in a timely fashion. Besides our tools, we also have these new services that we are providing. That as we are doing now online, we also give training for small teams, trainings that will cover exploit development, reverse engineering, even red teams, and like how to do a red team exercise, how to implement it, how to do it from a technical perspective. But besides that, we also provide pen testing services. So if you are in need of a pen test, if you are in need of doing any type of the services that we are listing here, not only web application testing, reverse engineering, static and dynamic analysis. So for example, if you have a tool developed in-house and you need someone to try to develop an exploit before real hackers do, meaning the bad actors do, you can use our expertise to not only do a dynamic and a static analysis or reverse engineering of your tool, but we can take it a step forward and try to develop exploits for your tool and that you have developed in-house, and maybe not enough users or maybe not enough interest on this tool, and you want to be secure. You want to be ready before that tool maybe reach the public. But if you are a small team, if you have too many pendants and you need some help, you need an extra hand, just give us a call as well. We might be able to help you. So having said that, let's begin with the training. So Mac internals. So what you will learn during this talk, you will learn about the Mac security application structure and how to identify security weaknesses in Mac applications. We will go also to MacSIP, system integrity protection, and dynamic library injections for that you, if you want to compare it, you can compare it with LD preload and load library, load library X. If you want to know more about LD preload, you think, hey, I don't know how LD preload works on Linux or Unix like BSD systems, or load library X for Windows. You can look on Packstorm Security or ExploitDB for exploits that use these two injection techniques, and then you can look for the exploit and try to learn about those. But on this, if you know of any of these two, you can make a comparison mentally of what we are saying today about the injection of Mac using dynamic library injections, because they are quite similar. And then we will do a deep dive into these two CVEs, at least on the CVE of 2023. That's the most recent one for the Telegram application that it will implement one of these techniques to inject a library and do some bypass. But first we need to talk about the basic application structure of Mac applications. So app bundles. If you are a Linux user, Ubuntu at least, you might be familiar with app bundles. App bundles like AppImage, there are other bundles, but AppImage is the most well known. There's a little bit of controversy with AppImage because some copyright stuff there. But in any case, it's quite similar to the app bundles of Mac. And here we will cover a few of the resources that are used on these AppImages. But there is here, I'm dropping a link for you if you want to look to the other resources of these app bundles. So, but here are the most important one. That's info process list. There you will have the bundle ID and the version. The Mac OS folder, that's where you will find the main executable of this bundle. There are other binaries, of course, mostly, not necessarily, but in most of the cases there will be more than one binary. But in the case of the main one, it will live there inside the Mac OS. That's where you will find the Maco or Macho binary for Mac. Then you will have the resources directory, where you will see the application resources such as images, HTML files, and so on. So inside the resource folder. Then you will have the frameworks directory with the frameworks and dynamic libraries for those frameworks and the binaries for those frameworks. You will find those there. Then you have the plugins directory with the application extensions and the launch services with the privileged helper tools to perform system level tags and XPC, for example, calls. Application sandbox and TCC permissions. TCC stands for transparency, consent and control permissions. And this type of permissions, if you are familiar with, or maybe you have an iPhone running iOS or Android, you might be familiar with this type of permissions, because when you are running an application, some application might ask you for permissions to access your calendar, your file system, your contacts, and so on. So this is the way that TCC, transparent consent and control permissions, are implemented in Mac. When you here on the right side of my screen, you see that I'm compiling a dummy application for Mac using Xcode. So here inside the app sandboxing, allowing this application to get outgoing connections client, and then this TCP permission will be granted to this application. It will be asked to the user, and it will be granted to this application. And this application, after that, it will get some entitlements. These entitlements are basically the permissions in the underlying part of the application. So basically, I will show you later a command on how to look for these entitlements. But these entitlements, they come from these TCP permissions, not necessarily, because there are some permissions, security permissions, that will come directly as an entitlement, not as a TCP, but when you enable this TCP, they will translate into entitlements. So for example, to access the internet, we have the capabilities of incoming and outgoing connections, which will automatically provide CompApple security network asterisk, so maybe everything, to entitlements to the application. To access the hardware, such as the camera. So if a program that you have running wants to access the camera, then you will have CompApple security device and entitlements added to your application, and so on. So capabilities and entitlements are two mechanisms that determine an application permission and access level. Capabilities define what the application needs to use, like the camera or the internet. At the same time, entitlements grant access and permissions for the application to interact with the operating system and other applications. So how do I test a Mac application? It's not you, it's Mac. So if you want to do graphical interface testing, choose like Windows and Linux. The first steps will be identifying potential user inputs, of course. So meaning whatever you can have access from the application, access to folder, files the application is trying to get access to. Typically, you will run applications monitors, just like Procmon or Process Explorer or something. So or dtrace. Or basically you want to trace the applications to see what are those inputs, not only of course the graphical ones, but what are the inputs overall for the application. Is accessing this, what are the permissions, and is using this type of permissions when it's accessing this folder, when I'm saving this file, that's another input, is saving a file, that's an input, or anything that is using as an input. You have to look at the app and make a map of all the inputs for the app. But beside the inputs that I just named, there are also the network side testing, that is basically look for the inputs and the access to the network. It could be that it's accessing a resource online or on your LAN or anywhere, but beside your computer is accessing a network resource, and then can you use that as an input to make the app do something? Basically, it's doing it because if it's accessing something and then it's showing that, I don't know, it's looking for a JSON file and then choosing playing that as a configuration or modifying the interface by using that JSON file, just to give an example. Or maybe it's doing something locally, as I'm saying, meaning this communication between process. Maybe is asking for a privileged action, or maybe doing an XPC call, or doing something locally to a stream, and then using that stream to get a type of execution, or that's something that you need to look for. But until here, as I'm saying here, it was all fun. It was all quite similar of what you were doing until here, right? Because everything what I'm naming here is basically the default type of pen test that you have to apply when you're doing a TIC-like type of pen test for an application. But on top of it, you have SIP. So SIP has been implemented since 2012 on Mac, and it's a security feature that prevents malicious software from modifying protected files, folders on Mac systems. It is restrict the root user, does restrict the root user. That's why SIP sometimes is being called as rootless system, even though you have root. But of course, if you have typically on Mac, just to name a few of the groups, you will have the system administrator, that is the root ID 0. Then you will have your standard administrator. So it's the admin of the Mac, meaning the user that will have access to sudo. And then you will also have the regular user. That's the user without admin access. So Mac after SIP can be because the root user has been limited, bunch, so quite limited. So you can call it as a Mac system that is a rootless, even though there is a root user and the root user is being there, it has been limited. How limited? Well, the system integrity protection comprises several mechanisms, including, and these are the limitations, and these are not all the limitations, but these are the most important ones for us, at least as pen testers. File system protection prevents any modifications to the /system folder. SBIN, so that's where you have your suite binaries, /bin and /user directory, as well as certain system files folders. Then you have, of course, runtime protection. SIP limits the ability to attach debuggers and prevents code execution. So you cannot attach a debugger. You cannot. So even though if you say I'm running this debugger as sudo and then I'm running it as root, you will not be able to attach a debugger into an application, because if you can do that, then you can modify the memory space and drop. Maybe you want to drop the memory of an application, and if you can do that, like in Windows, you can drop LSAS in the case of Windows, but in the case of Mac, you cannot choose attach to the keychain and then drop the memory of the keychain. You cannot do that. It will not allow you to debug an application if SIP is enabled. How do you check if SIP is enabled? But running here util status, and then you will see that by default the system integrity protection, it is enabled. And then of course it will also prevent you to execute code, to do code injection. No, not execute code. Well, you cannot attach a debugger and execute code, but you can also not do code injection. So you cannot do a code injection if SIP is enabled and the application has been compiled using hardened runtime. So if it's hardened during runtime, then it means that SIP will not load. It will not load libraries that are not signed correctly and are not allowed to be injected. And the injection of libraries is not something that we are doing as from hacking, but we are doing injection from a programming perspective. So that's the difference. And then, of course, kernel extension protection. It limits the installation of a kernel extension. So, meaning if you want to load a kernel module, so KX extension S, so you cannot do it. So rootkits, they are completely out of the questions, and you can only load kernel extensions, the ones that are signed by Apple. So you cannot load kernel extensions. So here I'm showing how I'm going into root. So this is my user, it's a regular user on the SBIN folder. I'm going sudo su, typing my password, then showing you I'm root. Now I become root. You see my user ID is 0. I belong to the wheel. Yeah, the root user belongs to wheel group. Group's wheel, and you see it's my completely a root user. But even though I'm root, if I go to the SBIN folder and I try to touch a file, this is touch hola, and then the operation is not happening, it's not permitted, it has been blocked by SIP, and the file has not been written. So here I'm showing you how using the command code sign -db, and then listing the entitlements of this application organism Mac. This is the output of the command, and it shows that this application has been compiled without flags, so meaning it has no security set for this application, but this one has been set with the flag 10,000, that meaning that is having it in runtime. So if I try to inject a library into this application, it will go through it with zip enable, and on this one it will not. Okay, next we need to talk about injection, dynamic library injection. So like LD preload in Linux, this is a colon separated list of dynamic libraries. So one or more to load before the ones specified in the program. So if you debug a program or you do a reverse engineering of that program, you will see that that program will call some libraries. Yeah, statically or dynamically will call some libraries. You can preload libraries. Well, in Linux or BSD is quite easy. The command that you use LD preload, and well, in Mac as well, insert libraries, and then you drop all the libraries that you want to load before the ones from the program. So all those libraries will get injected into during runtime in the execution of that program, and they are gonna be shared. They're gonna be shared and loaded into the temporary dynamically as new modules. So this technique can also be used in Mac as an ASEP type of technique, as every application installed has a process list called info process list that allows for the assignment of environmental variables using the key called LSE environmental. So what ASEP technique is an auto-start extensibility point, define mechanisms in the system that allow programs to automatically be invoked upon the operating system boot process or during the application launch. An example, so you can understand how this technique is applied, for example, on Windows, .NET. There are several ways of injecting libraries into .NET. And if you inject a library into .NET, then every time the machine restarts, if you set the proper environmental library pointing, a variable pointing to your library, every time you call a .NET application, it will auto-start your app. And you can do that during boot time or just every time a .NET application is called. And these mechanisms that I'm talking about, these are not hacking mechanisms or anything like that. These are features. Yeah, these are features that are used by developers to extend the functionality or test libraries. Yeah, we are using those mechanisms, these features in Windows, Mac, or Linux, typically to do code injection or privilege escalation. Because if you can inject code into an application that is after something is running with higher privileges than yours, then you can do some privilege escalations. Basically, you will obtain access, higher level access of your current user. But these mechanisms, these features, so-called, these are meant to be used by developers, right? Okay, how are these features implemented in Mac? Like this. So there are 4 different header commands, as I say, Mac whole binary can be used to load libraries. LC load dynamic library is a command. This command is a common command to load a dynamic library. LC load delete. Then you have LC load weak delete. This command works like the previous one, but if the dynamic library is not found, execution continue without any error. Then you have LC re-export dynamic library. This command is used as a proxy or re-export the symbols of that library from a different library. And then the last one is the LC load upward dynamic library. That is command is used when 2 libraries depend on each other. And this is called an upward dependency. So when there is a dependency, you will see these commands if you use programs like Procmon for Mac. and then you will see these commands being listed. And the most common one that you will see out there is lcload quick dynamic library. So this is the command that, this is the command that you will see mostly. But let me show you first how to load library, how to do it in on the most simple way, in the most simple mechanism, using dynamic load insert library, choose like with LD preload, but on Mac, and also show you how to do a list of the entitlements. So all right. So this will it for the sum up. I just have it prepared here. So I'm gonna run the command code sign -db, and then the arguments entitlement, and then the application, the app bundle. And then here you will see that I have the executable. Here is giving you this as an output. So it's telling me where the executable can be found. So it's here. Actually, we can also do this to see the type of exe that we have. And then the format is an app bundle, and the code directory, the flags that we have is hardened runtime. Yeah, the timestamp, signature, and so on, and of course the entitlements. So it is entitled to use automation Apple events, audio input, and audio camera because it's so right. All right, and but that means that we cannot inject. I will show you later how to do injection on applications in certain applications that are compiled with Hardened runtime. All right, so let's see an example of an injection. So I have this application. Hello world. So basically, when you run it, you just printf hello world. And then what I'm gonna do is to inject a library into the hello application. So hello is a macho 64-bit executable for LECs and 64, and the only thing that it does is just print hello world. So what we're gonna do is to inject this dynamic library into this application. So as I said on the beginning, what's going to happen is that it's going to inject this dynamic library. It's going to do a preload. So first, before any other library, we inject our library and then run it. So what's going to happen once we inject this library is going to call syslog. So it's going to import syslog. It's going to import standard input output, universal standard, and then the standard library. It's going to have a constructor, and here's the constructor. And what it does on the main is to call syslog. That's why we are importing syslog. So it's going to make a call to syslog, and then it's going to do a log of as an error. It's going to print a message in the syslog as an error, and it's going to do dynamic library inject. And then, of course, it's going to use also the name of the argument of the application. So if you want to inject it overall on every other application on your operating system, you want to track where your library has been injected into, you can do this trick and then see it on the syslog by doing the message. Then you will see, okay, my library has been injected on this application on this time, so you can track it if you are just doing some tests, like universal tests on your whole machine. And then, of course, as well, it's going to do a printf, but it's going to be happen only locally. In the case of this application, you will only see it on the terminal, right? And then, just because for the proof of concept, I'm gonna call exec b and then drop as an argument beginning with bash. So then if I show you like this, if I run the application just normally, you will just print hello world. And if I set dynamic library and set libraries to my new compile library, and then I call the application, the main app, it will inject my app print a message, dynamic library injected into, then by argument getting the name of the application, this one, and then choose dropping a bash, just because. All right, so having said that, let's go to the CVE for Telegram. I'm talking about this one because it's quite recent, but also implements what we choose learn today. So in this way, on this CVE, the application, the Telegram application for Mac, the client was by using this insert dynamic library insert libraries, was able to bypass the TCC of the webcam, meaning having get access to the webcam through the Telegram app. But here as well, what has been done is first look for the application. Application Telegram.app, that was the app bundle, and then he listed the entitlements. And as you can see, it has a bunch of entitlements, but besides that, you see that the flags have been set to none, meaning these applications have been compiled without hardened runtime. That means that you can create a dynamic library, compile it, and then insert the dynamic library as a preload in the application of in the context of the Telegram app bundle. Yeah. So when you run this, this is what happened. First, it dropped a message. Dynamic library loaded into. This is the message as has been dropped. Has been printed, and then you can see the message here on the example. Dynamic library loaded into, and then the name. And then this on this CVE, they created a more extended version of that dynamic library, not only printing a message, but also they were using the TCC that has been already available for the application to access the webcam. But what happened with the applications that are compiled with the hardened runtime? Here I will show you an example, and this is a housework that you can do. So it's something that you can do later. So if the application has been compiled using runtime, so meaning that you cannot load a dynamic library, then what you're gonna do? So if the application has been compiled using Electron, a bunch of the apps for Mac has been compiled using Electron, then you can look for HTML files, yeah, because then those HTML files. So basically, go to your bundle, you go to the bundle, and then look for HTML files inside those bundles. And if you modify those bundles, the application will still run, even though it's hardened with a runtime hardened. The application will still run with your modified HTML files. There inside, what you can do is, of course, call again Electron. You are required Electron, and then maybe drop a process, like do something, or choose create a child process, and then in this case, we choose running the calculator for Mac and do an exec of Mac. This should go inside the HTML, or you can even, if you are an exploit pack or control pack user, you can use our browser shell and inject those inside inside the HTML, and then you will have code execution. You can, if it's not happening, you can change the policies, the security policies, and then choose run it inside it, and then that agent will have code execution capabilities. And that's a way. As is today, this hasn't been fixed, so it is working. So if you have a Mac, look for in your app bundles your HTML files, and you will see that if these are compiled with the hardened runtime, if you modify any other file, the application will not run. But the HTML file, because they are meant to be modified, yeah, it will work. And it might even happen that if the application has higher privileges, you might be able to escalate privileges. This has been done in the past. All right, guys. So that's the end of this training. I hope you guys enjoyed the training, and well, I will see you. Oops, let's stop there. I will see you on the next one, and drop a message and here in YouTube, or join us in Discord. Or yeah, if you are interested and have more questions, we will more than glad to help you. Thank you, and see you on the next one. Bye.